throughout this whole chapter, we're going to be doing a lot of stuff with trigonometric identities, and I'm not going to take the time to write them all out. I recommend as you're watching this video to get a textbook and open it up to page 374. There's a list of a variety of different identities that we can use. Yeah. So one thing that we can do with those identities is something that we've already done in a different way. For example, we can say, well, we know sine theta is 2 over 3. Tangent theta is negative. Find the other 5 trig functions of theta. Now we learned how to do this by drawing a triangle, but we can also do it using identities. When we do this, we can always start with one of the Pythagorean identities, because those just have two trig functions in them. So if we have one trig function, we can find another. Now we do know sine here is positive, tangent is negative, so we know that that is going to be over here in quadrant 2. So all of our everything's in quadrant 2, so we know that our angles will the signs of our answers will be quadrant 2. But the Pythagorean identity with sine is sine squared plus cosine squared equals 1. Sine squared of theta plus cosine squared of theta equals 1. And this notation looks a little bit weird. They attach the exponent to the function instead of to the variable. This means the same thing. You take sine of theta and square it. That's what this is. So we know sine theta is 2/3, so we can plug that in. Say 2/3 squared plus cosine squared theta equals 1. 2/3 squared is going to be 4 over 9. And we subtract from 1, so then we get cosine squared theta equals 5 over 9. So cosine theta is going to be root 5 over 3. Now in general, since this is a squared, that would be a plus or minus root 5 over 3. However, if we know we're in quadrant 2, then we know cosine should be negative, so we know that the negative answer is the correct solution. Now that gives us sine and cosine. So from sine and cosine, we can solve for tangent theta. You could apply, you could take reciprocals and then apply a Pythagorean identity as well. That would also work. There are multiple different ways you can go about this, but I would always use a quotient identity next. Tangent is sine over cosine, which is that. So tangent of theta, 3's cancel out. It's going to be minus 2 over root 5, which we rationalize. And we get that tangent theta is minus 2 root 5 over 5. And once we have these, we can just take reciprocals to find all the rest. We know cosecant theta is 1 over sine theta, so cosecant theta is just going to be 3 over 2. Similarly, secant theta is 1 over cosine, so that's minus 3 over root 5, which is minus 3 root 5 over 5. And cotangent theta is the reciprocal of tangent, so minus 2 over root 5 was tangent, so cotangent would be minus 5 root 5 over 2. Right. So that's how you can go about doing that. I'll do one more example, and this is particularly to illustrate a point. Let's say tangent of theta is minus, I don't know, 3 over 4. No, let's say 3 over 5. And cosine theta is positive. Find all the trig functions using identities. Now, something that people do that is incorrect at times is they say, oh, well, tangent is 3 over 5, and I know tangent is sine over cosine. Therefore, sine is 3 and cosine is 5. That is wrong. the sine of theta and the cosine of theta have a maximum value of 1 and a minimum value of -1, first of all. But all this means is that they're in a ratio of 3 to 5. It doesn't tell you what either one of them is. So don't do that. Your first step in one of these problems should always be to use a Pythagorean identity. So the one that we can use right away here is that 1 plus tangent squared of theta is secant squared theta. So that's 1 plus 9 over 25 equals secant squared theta. 1 would be 25 over 25, so that's 34 over 25. Take the square root. We get root 34 over 5 secant theta. Cosine's positive, so secant's going to be positive. I didn't stop to think about it, but if cosine is positive, tangent is negative, that means we're here, quadrant 4. Yeah, so secant's going to be root 34 over 5. And then, well, the quotient identities include sine and cosine, so I have secant. That means I can get cosine. It's going to be 5 over root 34, which is 5 root 34 over 34. And then I can use that tangent theta is sine theta over cosine theta. And plug in what I have. Minus 3 over 5 equals sine theta over 5 root 34 over 34. So then I would multiply 5 root 34 over 34 to this side. The 5's cancel out. I just have 3 root 34 over 34 negative. And then I just need to take reciprocals. Tangent's minus 3 over 5, so cotangent is minus 5 over 3. And the last one I need is cosecant, the reciprocal of sine. And cosecant would be 34 over 3 root 34, which we need to rationalize. And here I wanted to do it this way because people do something silly here a lot of times. People will write minus 34 root 34 and then multiply out 3 times 34. Well, we've got root 34 times root 34. So we know that's 3 times 34, but don't multiply that out. You've got 34 in the numerator too. So, yeah. So then cosecant is minus root 34 over 3. So that's how we can use Pythagorean identities to solve for trig functions. Now, the main bulk of this section is going to have to do with simplifying trigonometric expressions. And in order to do that, well, we need to know what it means for a trig expression to be simplified. So when we're looking for simplest form, we're looking for a few things. One, we want the fewest terms that we possibly can have. So like if it's sine x plus cosine x, that's 2 terms, whereas if it's sine x times secant x, that's just 1 term all multiplied together. So we want the fewest terms. We also want no denominators, if possible. So we always want to take any trig functions in the denominator and instead write it as the reciprocal in the numerator. For example, if we have, I don't know, say we have, you calculate and you wind up getting 2 over cosine x. Well, that has a denominator. Change that to 1 over cosine x. We can rewrite. You can write it as 2 secant x. So I'll pull everything up to the numerator as you can. And then we also want the fewest powers of trig functions. And an example of that is, say you wind up with sine squared theta over cosine theta. Okay, well, one way to simplify that, if we follow what I just did before, one thing you could do is say that that's equal to sine squared theta times secant theta. Okay. not told me you could do it. But you notice sine squared, well, there's a sine over cosine there. So that could be like sine theta times sine over cosine. We do that, sine over cosine is tangent. So then we have sine theta times tangent theta, right? And we see here this has 2 powers of sine, 1 power of secant. So this has 3 powers of trig functions. Whereas this just has 1 power of sine, 1 power of tangent. So that has 2 powers of trig functions. Therefore, this is simpler. So that's what we're looking for when we have simplest form. Right? So what we're doing here is making substitutions based on our trigonometric identities that will help us to simplify. And a key thing that I want to say, 2 things, I guess. And it has to do with attitude and what you're, how you're thinking about these problems and how your emotions are as you're dealing with these problems. And sometimes it's hard to figure out what you're supposed to do. That's just it's true. There isn't a, unlike other things, there's not a rule for I always do this every time. In the last chapter there were a lot of things to memorize and procedures to follow to graph things and to things you had to memorize of what the values of the trig functions were and all that. This is a lot more having to figure things out without a lot of information that you need to know off the top of your head. So that's, some people might like that better. Some people, it's harder. Maybe for most people, I think it's harder. First thing I want to say, always try something. You might be able to look at something and just see it right away and plug it in and it works well. Sometimes you might look at it and be like, I'm not sure what I should do. Try something. Use an identity. Plug something in. Turn things into sines and cosines. Put it together. Do something. If you raise your hand and say, Mr. Parkhurst, I need help, and I come over to you and your paper is blank or you've only written the problem, I'm not going to help you. Because it's very important that you just try something, plug something in. You might wind up going off in the wrong direction sometimes, but you definitely can't figure out the answer or figure out a solution to the problem if you don't try. And the second thing is related. Persevere. Keep trying. If you are doing stuff and it seems like the expression is getting more complicated or like it's looking weird, start over, but try again. Like keep on pursuing the solution. This will be, you might hit some dead ends, but they'll help you to figure out what you actually should be doing.